Good afternoon, everyone. My name is Christy Ford. I'm the account executive at Online Resources and your moderator for today. We would like to welcome everyone to today's 3D Lunchbox webinar, A Model of Excellence. A special welcome back to those of you who have joined us before for the previous webinars, and thank you all for taking a few minutes over your lunch to be here with us today. As a reminder, please turn on full screen mode for better viewing of the presentations. And if you have any questions, we encourage you to go ahead and type them in as we go, and we will answer those at the end of the presentations. Let's jump right in. Here with us today is JD Schomburg. JD is the VP of Operations at Online Resources. He's been with the company for the past 8 years and has been a part of 3D data collection for the past 19 years. We do have a couple of special guests here with us today. Here from Peerless Pump is their quality engineer, Matt Cary. Matt graduated from IUPUI with a bachelor's in applied science with an emphasis on organizational leadership. Matt has been in manufacturing for a little over 37 years. In 1997, Matt joined the team at Peerless Pump and for the past 20 years has been in quality control. He is currently a quality engineer focused on inspection and testing. Welcome, Matt.
Thank you for having me. I appreciate it.
We also have here another special guest. We have Adam Waraksa here from Octon, which is the parent company for Geomagic. Adam is an application software engineer at Geomagic. He has been in the 3D scanning and engineering market for over 12 years. In his current role, he is responsible for supporting the Geomagic software products. These products are used in a variety of markets, including medical, aerospace, industrial manufacturing, mining, construction, public utilities, and transportation.
All the things, all the things.
Yeah, well, welcome. We're glad to have you here with us.
Thanks for having us out.
We do have a lot to share with you today, so let's go ahead and get the ball rolling. For those of you who are interested in learning more about either one of these companies, we are going to throw those links into the chat for you. JD, do you want to start us off? Just talk to us a little bit about scanning technology.
Sure. Yeah, so we started Online Resources. Their powerhouse really is 3D scanning. And so Peerless Pump has a Metroscan from Creoform. So we have a guy over, Derek, in our lab. Looks like his camera just came up. He is going to be showing us the Metroscan Black Elite from Creoform. So this is a system that collects 2.5 thou accuracy in a 600 cubic foot volume. It also has blue laser lines and a lot of them. So you can just see how fast that data collects. And typically, like CMMs, we might be getting, Matt, maybe 1,000 points on this kind of part.
Yeah, traditionally we were scan this on the basically utilize the scan mode in the 3D on a CMM. We'd get maybe 1,000 points. If it's in the manual mode, probably a couple hundred.
Okay, so and with the scanner here, we're looking more so at 100, 200,000 points. So we're able to really increase the data volume and really look at a full surface analysis of the part with that kind of scan data. So Derek, thanks for scanning that for us. If you want to go ahead, bring that part over, that'd be great.
So Matt, as we're here talking about 3D scanning for inspections today, how exactly are you using it?
When we initially came into the 3D scanning, it was because 3D modeling had first come out, and we needed a way to do more of a dimensional inspection because now we have a 3D model to compare it to. When we initially brought it in, it was for the new products, and what we were doing, we were changing existing products, so we had to get a baseline for our existing, and we deemed those what we call a golden part as such, or first article part that we could scan and then later compare that back to either the new product or existing product to see the variation and the changes that we've made in it.
So how were you guys doing this beforehand?
Oh, traditional gauging methods, also along with a CMM, and each one of those would basically, we utilize an Excel spreadsheet to convey the information. The biggest issue that we have with, not an issue, CMMs are great, but they're a large learning curve over the top and fixturing. As we saw, this part was basically scan in the orientation it's currently in a matter of less than 2 minutes. We couldn't get it loaded onto NCMM within 2 minutes, and then it's going to take anywhere from 30 minutes to hours to get all the points that you're looking to get.
And that's if you're next in line for the CMM.
That is correct. Then you also have our parts can be very large parts. That's the other volumetric piece of the puzzle. Your volume on a CMM is quite small in comparison to what you can do with this. That was another huge selling point for us to get into it. Just looking at the logistics of some of our parts. Some of our parts could fit into you couldn't get them into a 6-foot cube. So
yeah, that's a perfect example. And then we've also done, I'm going to go back a little bit because I know a little more. We've done kind of the whole spectrum of your manufacturing process, from patterns to core to final part. How has it been used really and pushed you to the next level in each of those areas?
Well, exactly. That's a very good point. What it takes to come to a part like this, first you have to have traditionally 2D drawing that goes to a pattern maker who has to interpret that 2D drawing and basically come up with their magic interpretation of it. Very similar to the difference between reading a book. If I read the book and you read a book, and we come back and we talk about the book, and we could be in two totally different areas of what we thought the book was about. But then we go and see the movie and we go, I see what you're talking about now. I see, or the director's point of view. And that's the same thing that we run into with this. With this type of technology, I can very easily talk to somebody else and show them the 3D scan at that point in time. And we are able to communicate very well at that point in time. It leaves a lot of the guesswork out of it at that point in time.
Yeah, and that's really cool. I love that analogy because we're really visualizing the whole part. And that's really done through the power of the Control-X software. So how are you utilizing the Control-X software to really get the information out that you need?
We will generate a 3D PDF, and that's where we're able to go in. We can actually do cross sections. That's where a lot of that data and Excel spreadsheet type of data is going to be kicked out through that, and it will show you where you're minus in one area and plus on the other area. But what it gives you is it gives you an overall picture. You have to take an Excel spreadsheet with this same type of data that you're gathering off of a 2D print and really start trying to piece this puzzle in space of what you're looking at. Like, well, okay, I think what we're looking at, and this is where I think we're having the problem at. This gives you a picture, and a picture is worth 1,000 words.
Is this vein 4 or 6 or where
exactly.
are we right here?
And not only do you get that 2D picture, you get the 3D, and you're able to rotate it and say, oh, okay, well, it's good on this side, but you rotate it, like you say, okay, and now I see how this affects that affects the other. So when you see a problem down here, it's actually caused by this up here. And it really gives you a good starting point to be able to get that information across the board.
Yeah, that's really cool.
Yeah, I think as we talk about this concept of inspection, that's one of the reasons Adam is here with us today. I wanted to bring him in so he can tell us a little bit more about Control-X and how it's impacting the inspection process and the results we see from it. If you wouldn't mind just kind of sharing that with us.
Yeah, so Geomagic Control-X, it was really, Geomagic's been around for a long time, so we've been doing things with inspection and reverse engineering for probably about 20 years now, depending on how far we go back.
Longer than I've been in the industry.
I was probably in high school when they started, yeah. So I'm an old man now. So, but so how this program really came about is usually the sticking point for using like any software is kind of ease of use. So, and a lot of the quality control software out there is you kind of if you hand it to someone that's even an engineer or a CAD designer, they may there's going to be a big learning curve to it, and especially the CMM softwares and things like that. And then programming, it's like being a machinist. There's a lot to learn. Whereas we really wanted to make it so it was super simple. So we just created it so it was more like a CAD program and like other software that people know how to use. And the layout's very functional, and the workflows are very easy to move through. So people can literally come in, if they have CAD models, drop them in and start adding their GD&T to them. And then for the golden part scenarios, like you guys are mentioning, it's make it very easy to pull out data and extract that and then compare your other parts back to it.
Yeah, and I'll say it really does feel very similar to like the CAD packages, like the workflows and the feeling. So like even someone who's never stepped into an inspection software, if they have any kind of CAD experience, it feels like a very natural transition.
Yeah, one of the goals was really in the UX was like, how can we create this so if somebody sits down with it that has some general engineering experience, that they can kind of figure it out, without having to really read a bunch of books and take a course and stuff.
Yeah. So what are some of the like power points of Control X, like the strong areas?
Yeah, so I mean, to be able to do the golden part, we make that really, really simple. And I actually have a couple of pieces of data, and I'm sure he's pushed that data over to me by now. So we can throw something down if you guys want to see it. Yeah. So
we would love to
throw
see
a couple
that.
dims on something and
Yeah.
how we use regions and stuff.
Yeah.
I like the lingo dims. That's cool. Yeah. So while he's getting over there on his computer, so we're gonna be using the gold standard type, so scan to scan comparison.
Yeah.
Okay, so taking one of the scans and actually making it like your nominal CAD data set.
Yeah.
Okay.
So this is this is the nominal data that we brought in. So this would be like something we would have that we pre-machined, just like we have this one machined here to be able to check the two of them on the insides. So and then what we do is we actually come in and we stole something from Design X and we put it in Control X here. And Design X, for those of you that don't know, is our reverse engineering software. And we've always kind of had this ability in here to auto segment and pull out things like planes and cylinders and all that stuff. So we actually use that in here. So normally you'd have to go through and I'd have to highlight data and I'd have to say extract a plane from this or extract a cylinder out of this. But right now you see with these colors, if I come over these regions here, it'll actually tell me like what things are and classifies them out. So here's, pulled out the planes and things like that already on the data sets. And I can, I can still use what data I want, but the regions are there to speed up everything. But with the advent of the regions here, I can use this essentially like it's a CAD model. So if I was doing setup on this and I'm like, hey, we want to get a height, of our shaft to shaft position here for like our input flanges. So I come into my dimensions just like I would in CAD, and I hit linear dimension. I can click on this plane here, go to the bottom of my part, and you can see I don't have to actually go through and do that manual like highlight out. So and now this is the actual dimension that's on that golden part. So
that's your nominal dimension.
Yeah, that's the nominal on the golden. Yeah. So and if this may not be the nominal on a print. So maybe we want to check back to this as a golden part. Like maybe there is baked in tolerance in here that they want. We want to keep this number exactly the same. But, if we want to override and say, hey, this should really be 4.5, and we really want to put the tolerance on that, I can overstack this. So now when I compare another part to it, it's going to put my tolerance on the 4.5 inches. So it just makes it really easy to set up, and I can drop my tolerance on there and hit OK. And then once I put in, here we'll throw one more dimension on here just for fun, so something else populates here. We'll put on our bore diameter here for our cylinder and stack that out. And then again, this has a fit on it, so we can do our print for our fit if we want to, and then tweak the number a little bit. But that's the actual dimension with the slip fit on it with the keyway. So leave them in there.
So literally within like 4 or 5 button clicks, you already have 2 dimensions set up.
Yeah, and we can set up all kinds of other stuff that we might want to pre-program. Like if we need specific points on these curves and things like that at certain heights, like we can come in and do that and have this all set up, because the whole point is being able to do repeat parts really efficiently. So like when I come into repeat parts, I'm going to drop in some information and basically hit rebuild. And then I actually have data like pulled in here. So I'm going to just basically input this back into my result here. So
and this is where the true magic actually comes into play.
Yeah, this is where all the fun starts to happen. So now that I have that stuff in here, I have a 3D compare that I baked in here a little while right before we started, just so we can get a color map and things like that.
You were talking about this 3D comparison.
Right. This will give my eye. It'll show me exactly where I need to be focused on the overall part. and then I can actually go in there and determine whether what to do with that information, what needs to be adjusted or whatnot, and then be able to communicate that back to, let's just, in this particular case, it's going to be the foundry that we're going to create, come back to and say, okay, this is what we're seeing, and then they can actually translate that into what they need to do with the pattern, which is usually the direct opposite of what we see here. I say, I don't have enough material here. They said, okay, well, we'll remove material off the pattern, which will give more material to the part.
So, and what we can see here is like, as soon as that aligned and rebuilt, okay, which is basically how we're going to do repeat parts, I can just keep bringing in new data sets and we rebuilt. So now my dimensions lit up green here because they're intolerance. If they were not intolerance, they would be red. But, and I can visualize the deviation and stuff in the bottom of like what's there between scans. And like, on these parts is even if it's the same part, as we rotate these, there's gonna be different tolerance and then stack up for the castings.
So this is just a very simple pass-fail visual right there.
Yeah,
Like,
I mean,
you
as
can
soon
set
as
it
you
up to
bring
just
it in,
pass-fail.
yeah, it's just instantly like if I saw red flags coming up on my dimensions, I know I'm out.
I like how you say it's a simple inspection on a very complex part,
Very
extremely complex part, for somebody to come in there and manually do that. And mind you, you'd have to do that on one impeller, the next. He was able to do it in a matter of minutes.
Yeah, and I like how you said one and then the next, because I think, Adam, what you're saying is you've created a report, and then after that, you just next part, and it's going to spit out the same report.
So I have my color map on here, and usually we'd come in and there's something, some stuff we'd want to communicate. You want to communicate something back to the pattern shop, like we see that there's a high spot here in this radius.
Mm-hmm.
That came out of the casting. So of course we can throw a comparison point tag on this that they're going to be able to note the location of and things like that. And then what we can do is, if we get into, going back to really checking with engineers, or even if you're patterning, this old part to create a new part from it, there's a lot of interesting things we could do. We have these simulated CMM points, which are super handy. It's basically creating virtual probes, just like you would in a CMM, but getting down inside of here on a CMM to get a specific location at a specific
Near
point.
impossible.
Really hard to do, yeah. And I mean, I can't tell you how many times in my past I put something on a CMM bed and I go to get the probe that I need and I put in a CMM and I go to drive it over and I can't reach what I want.
It's only a $600 probe, so if you snap it, it's okay.
Yeah, don't break it.
Just grab another one.
But so like this is creating virtual probe points. So like I have it set up for 1/8 inch diameter ball, and just searching that area. And the like engineering and stuff on these curves, mathematically, they can give me locations where they want data, and I can come in and easily probe those points to crazy, French curve essentially that's on there. So
yeah, and I like how we're being able to see present the data to how people like to see the data. So your CMM guy, that's what he's going to want to see.
Yeah,
is
right.
That point.
Right.
How does it react? But then, like, if you're making the pattern, you want to know, okay, what's the overall situation?
Correct. Where this is a huge benefit, we'd like to say, well, we have one pattern. Well, nobody wants to have one pattern. They want to have multiple patterns, all identical. Well, there's no such thing as identical ever. There's always some sort of variation. It's just how much is that variation is going to affect your overall end product.
Yeah.
And we want to have a zero impact. This helps us maintain the tightest reference from one pattern to the next. We can very easily compare the two parts together and say, okay, this is the golden one, and these are variations of the golden one, and we need to bring those in to what this is. Very similar to NIST standards, where you have the golden 1 inch over here, and then you split that off.
Definitely.
And further and so forth.
Yeah, and then pushing out reports. I mean, you can configure reports however you want, and like we can have all kinds of data stacked in here for different audiences essentially in one file, and then have multiple different types of styles of reports. So we can have the quality report that's literally just the dimensions and some hit points. We can have a report that we might send to like engineering for R&D, one to the pattern shop for like the color map and comparison points that they want to see, and then it's not all really jumbled together.
Correct.
So,
and where we find a big, you can actually go in here and do a cross section, and then put that cross section within. Not only do you have the 3D in front of you, but you also have cross sections where you can drop the tags on them and such like that.
Yeah, see curve deviation on all that stuff.
And that's knowing more of which audience I'm sending the report to. Some audience like, I don't need that, I need this.
Yeah. And then for, repeat part, again, once this is all set up and the reporting, is configured, we're going to hit replace measured data, and we can drop them in one at a time. If we're just having some stuff come out of the shop, like maybe I have 10 parts that somebody brought in last night and they scanned up for me when I got in. So I can actually come in here and do a batch process on all that data and just let it cook.
That's nice.
Yeah.
So if you're multi-shift, one shift can
yeah.
be scanning, and the next shift can then process.
But I can get someone, collect data, in the morning, or I could scan data in the morning and just keep doing that same type of thing for the 10 parts I need to do. And I go to lunch, I just hit batch, and I don't have to tie, I'm not tying up the computer while it's processing while I'm doing stuff. Now it's only a couple of minutes to batch each part out, but but still, if I have a dozen of them, it's going to take like 10 minutes, so I can at least get a coffee break.
Yeah.
But and we actually have full automation ability too, where we can you can dump stuff from the scanner, and we can actually tie that to what inspection project is there, and it'll automatically run the inspection and dump reports out or things like that.
Yeah, and that's a really cool feature, and that does work with the Crayform systems.
Yeah. So but that's kind of a one-hit wonder here in Control X, but simple to use, easy workflows, CAD style dimensioning, just makes your life really easy.
Awesome.
So in theory, we could take 10 of these parts that came in and scan them. Let's just give them 5 full minutes from. We're looking at about an hour worth of scan time on 10 parts. Another hour, let's just say, for comparison, within 2 hours, I have full dimensions, everything I can send out on 10 parts that, if I was doing the traditional way, would probably be at least a day's time, if not 2 days' time, and not have nearly the information that this gives us.
Yeah.
What a huge benefit. I mean, with you using Control X, you have firsthand knowledge of this, and I think time savings is huge in today's world. And it sounds to me like communication is the other key component that you can now communicate across to several different audiences.
And how quickly can I do that? That's the other thing. Because like I said, 2 hours I could have a report out around the world to 10, 20 different people or whoever needs to see it within 2 hours. To where the traditional, you still have that lag time. It would be 2 days just getting through inspection, which is going to bottleneck that particular inspector until they're able to get through it.
Yeah.
And in some cases, we've seen where traditional inspection would not have caught the deviation.
Wow.
We would have said, we got a problem here. Where is it?
Yeah, the scan data and color map, I can't tell you how many times that I've even just gone in and people have been hunting stuff in CMMs and doing traditional types of inspection. They tell me before we even talk, when they start looking at scan technology, and I'm sure you've seen the same thing, but
yeah.
So they're like, oh, we've been trying to figure this out. It's like, well, how long? And they're like, we've had parts and we've had issues.
Couple years.
Yeah, like a couple years. It could be 4 months, couple years, like whatever. They're trying to hunt something down. And you go in and scan it, and I do like a CAD overlay or something back to a golden part that they know is good. We throw it on there. We pull a couple comparison points, and like every one of the quality people and engineers in the room is just like, oh.
Yeah, and I mean, we've seen that a lot.
You did that in 15 minutes, and like we've been hunting at this part for 4 months, or 6 months.
Or they're like, well, we fixed this, but then it still doesn't fit on. It doesn't mate. It doesn't do this.
Yeah.
We can't figure it out. Well, because that actually affected this, and this.
Yeah. We had 2 mating parts that were supposed to come together, 2 new parts, but when we went to fit them up, there was something internally that was keeping them from mating up, and we checked both of them dimensionally, and they were just spot on the money. Of course, you have print over here, so we said, you know what, let's scan them and then bring them together virtually and see if we can find out what's holding it up. And it was one of these light bulb moments. Oh, it was 2 angle pieces, a cone, male and female cone.
Mm-hmm.
One was cut at a 23-degree angle, and the other one was cut at a 32-degree angle. So somebody
had a dyslexic guy there.
Yeah. So it's like we're making everything to the prints, but
right,
with the virtual assembly, especially if you just do the data, so you don't have to put models together or anything like that. You're just checking fit.
Yeah. So it became quite obvious that once we did that, this makes total sense now. And that's what I was talking about. Your traditional inspection can only go so far. And basically, if we would have had 3D model, we probably would have caught it. Yeah, I'd like to say we would have caught it with 3D models,
Yeah,
absolutely.
yeah.
But
Well, there's times too. I mean, like everybody in different families and stuff like that. Like, as you have pumps with different configurations. So like in the same housing, you might put different impellers for different applications or different types of
Correct.
fluids or whatever else. So it's like, they're pulling stuff from product catalogs and they're like, hey, we're going to use this and that, and they should fit together because they were designed like kind of at the same time. But catching something like that, you see it right away in the scan data when something doesn't work
and
out.
I feel like the casting industry is just notorious for this because it involves so many different kinds of manufacturing processes that have varying tolerance levels. So you might go from pouring the metal to a machining process and you're going to have to communicate to all of those guys along the way of where in your area,
yes.
How are you doing?
Yes.
Because we typically just put the final part on the CMM and say,
check
everybody's like, well, no, mine was good. Where's yours?
Yeah, that's usually where we get the biggest discord between departments, between the foundry and the machining side. If there's something that goes awry between the two of them, I don't want to say intentional finger pointing, but the casting guy will or the founder will stand behind it. This is what you requested, and guess what? It does meet print spec, but that leaves an envelope in there that the machinist has to be able to work with as well. And the machinist can say, well, it's not the way that I would expect it to come in. So that's when we had to be able to bring the data together. And we found one of them. This has been two sister parts where they were identical as far as we could tell. But when it came to machining, there was a night and day. We could not have the lots come in and mix them together from two different suppliers because it would just wreak havoc on the machining. Now you could start with one and get the first piece set up for the one batch and it would run just fine. And then you could do it the second, but you could never intermix the two. And then when we actually got them together and we put them together, we found, yes, technically both of them meet print specification, but this one was running, I'm just going to say the OD on the high side, and this one was running the OD on the low side.
Yeah.
And that made a night and day difference.
And putting that in a machining fixture,
correct,
in the same machining fixture, you end up running out of stock or something in another
right.
location. Yeah.
The jaws aren't closing down, not clamping tight enough, or I can't fit into the jaws because there was that much of a deviation. It comes down to machine stock that we talked about.
Yeah, and that's very interesting. Just having that supplier A, B both be right on target, but they might be a little high one side, a little low the other side, and what do we do?
Exactly.
Yeah.
Well, I hate to interrupt this conversation. This has been great today, and we really do appreciate you both being here, but we are running out of time. So I do have one question that came in that I just want to make sure we answer here today. Kind of a fun question. This sounds complicated. How hard is this to implement into your processes?
Anything that you're learning straight out of the gate seems overwhelming and complicated, but relatively quickly came up to speed.
And that's what we're here for.
Exactly. I was going to say the training, highly recommend the training. One thing that going into it, I know we wanted to, we said we need to bring in our parts and you train us on our parts. And that's not exactly the best training picture, I will tell you right now, because how you're trained has nothing to do with the orientation of the parts at the end of the day. If you learn how to do it on one part, you can take that information and move it on down the line. But overall, the training was very, very well handled. And they said, now you just need to go back and use it. That's the key to everybody. You have to go back and use it. If you don't, if you wait a couple, 3 or 4 days and come back and you go, where's the on button?
So. And yeah, this really is an easy software to use. So training most of the time is people can get up and running in a day's training class. And then any other hurdles that come along, which you always will when you come up against something new, that's what we're here for. So we always say, like, if you can't get through it in 10 minutes, call us because one of our guys can help you get through it probably faster than 10 minutes.
Absolutely. We ran into, with COVID, like a lot of businesses, everybody stayed away. We still did their manufacturing, but we had a lot of us were working remotely, including myself. So I really leaned heavily on what they were giving me from the factory as far as their scan data and stuff like that. And then working remotely doesn't help because you're trying to relearn everything. You don't have anything at your fingertips. And there's several times where I had to call you and say, hey, look, I got an issue. I don't remember exactly how to do this. And you guys were able to walk me through it.
And that's like one of the benefits of scan data too. Even if like you are remote, like if you're getting CMM reports or other measurement stuff in the shop, like you'd have numerical data to go off of. But when people are sending you scan data, it doesn't matter where you are. Like there's no hiding anything. There's no questions. Like you can always drill down and find the answers you need.
Exactly.
Yeah. So I think it's pretty easy to learn.
Yeah.
And for any hurdles, we're here to help.
I love that. I hope that answered your question. Thank you all. That is all the time that we have today. If your question did not get answered, I have recorded it and one of our experts will be in touch with you in the next couple of days. Thank you all for joining us today. That was a wonderful episode of the 3D Lunchbox series, and we're grateful for your presentation and your expertise. It's exciting to see how 3D scanning coupled with Control X are transforming the inspection process in the casting industry. And, you know, that's exciting to be a part of it too.
Yeah, cool. Thank you.
As always, if you have any additional questions or needs, you can call one of our experts at 765-482-9700, or you can reach us via email at support@onlineresourcesinc.com. Thank you again and have a great afternoon.
Cheers, guys.